Hi all. Welcome to the third session of Speed, Distance and Time. Taking forward the basics from the previous class, let's try to understand how do we solve different types of questions given to us and what is the hint that each and every question throws on us. Okay. So if I go ahead and read this question, all I'm looking at it is, I'm told that the ratio of speeds of x and y is 3:4. If the time taken by y over a certain distance is 48 minutes, then find the time taken by x to cover the same distance. Now, what are the points that we need to understand? The most important hint that the question is giving us is both x and y are covering the same distance here. If x and y are covering the same distance, I can say that the distance covered by x is equal to the distance covered by y. Okay. So what is distance? Distance is nothing but speed into time. Okay. So this is speed into time. Now I know the ratio of the speeds is 3:4. So let me take the speed of x to be 3k and the speed of y to be 4k. And I'm told that y takes 48 minutes to cover the distance. So this into 48, I do not know how much time does x take to cover the same distance. Now please understand, if this is in the form of minutes and this is also in the form of minutes, the uniformity is taken care of. So we need not divide them by 60. So what do I see? I see that k gets cancelled. This is 3 ones this is 3 16s or the value of x is equal to 48. Sorry, 4 into 16 is going to be 64 minutes is the time taken by x to cover the same distance. Right, this is one way of looking at it. Now what is the other way of looking at this? Now please understand, speed, distance and time are proportional to each other when the third thing remains constant. As it's said in this question, distance is constant. Now when distance is constant, what will be the relationship between speed and time? So if I'm going at a faster pace, the time taken would be eventually reduced, right? So therefore, if distance is constant, I would say speed is inversely proportional to time. If speed is inversely proportional to time, we would know that s of x by s of y, clear, will be equal to time taken by y divided by time taken by x to cover the same distance. Now if I just plug in these values, I get the answer directly here. So I know that the ratio of speeds is 3:4. Y takes 48 minutes. I do not know how much time does x take. So this becomes 3 ones and 3 16s is 48. When I cross multiply, I get the value of x is equal to 64 minutes. So if I'm given time directly or the ratio of the speeds and I know that distance is constant, we can start applying the proportionality that speed is inversely proportional to time, right? A very basic question. Now let's look at this question. So this question says the ratio of speeds of x and y is 3:4 and therefore x takes 20 minutes more than y takes. And there's a full stop, which means to cover the same distance is what we have to imply from the question. Most of the times these kind of statements will not be given to us, right? So it's indicated that the distance that's covered by both of them is same here, right? Now if the ratio of speeds is x 3:4 and the distance is constant, we know speed is inversely proportional to time. This question says what is the ratio of time taken by x and y? If I know the proportionality concept, I can just reverse them and get the value called 4:3. Clear? If we want, we can also go ahead with the concept of distance being constant. Okay. Now what am I looking at in distance being constant? And distance being constant, we are looking at it as the distance covered by x is equal to the distance covered by y. Similar concept the way we did in the previous question, right? So if 3k is the speed taken by x, right? I'm taking 4k is the speed taken by y. Right now x takes 20 minutes more than y. Let's say y takes t minutes to cover the distance. So x would take t plus 20 minutes to cover the same distance. Now if I simplify, k and k gets cancelled. Now what am I left with? We are left with 3t plus 6t is equal to 4t. Or when we transpose the values, what do we get? We get the value of t is equal to 60 minutes. But what is t? T is the time taken by y to cover this distance. Okay. So therefore, the time taken by x to cover the distance is 20 minutes more. So the answer for this question is x takes 80 minutes to cover this distance altogether. But this becomes a slightly lengthier approach, as I told you. Whenever I know that distance is constant, the first thing that should come to a student's mind is the proportionality between speed and time. Okay. Now, what is the time taken by x? Now, this question is asking us the exact time taken. Let's try to use the ratio here, because if the ratio of time taken is 4:3, so I would take, let's say, x takes 4k minutes and y takes 3k minutes. And I know that the time taken by x, that is 4k, is 20 minutes more than the time taken by y. Clear? So what do I have finally here? So I finally look at this as k is equal to 20. If k is equal to 20, what am I looking at? I'm looking at 4k, that is 4 into 20. So time taken by x directly here becomes 80 minutes. So I need not go to the longer approach. I can directly use the ratio, especially when distance is constant. We can apply this concept and we can also keep moving forward. Right? Let's move to the next question. Now, walking at 4/5 of his normal speed, David reaches his office 15 minutes late. Okay. What is the usual time taken by him to cover the distance? So what does this plot talk about? Every day, David goes to his office at some speed. Okay. So let's say David goes at a speed of s, and since I'm told about 15 minutes late, let me assume that the time taken is t in the form of minutes. This is usual time. Okay. Now what happened that day? He is covering the same distance. Now this is what we need to understand from the question, that every day he is covering from the distance from his house to office, right? So the same distance has to be covered at what? 4/5 of the speed. So 4/5 of his usual speed. Clear? And he is reaching 15 minutes late. If the usual time taken is t minutes, today he is taking t plus 15 minutes. Clear? Now we need to understand this very clearly, guys, that till when the question is not asking us the distance, taking minutes and minutes will not affect our answer. Okay? But on a safer side, let's divide this by 60. Let's also divide this by 60. Clear? So what am I looking at? S gets cancelled, 60 gets cancelled. Let's cross multiply. We get 5t is equal to 4t plus 60, or we get the value of t is equal to 60, and we have assumed t is minutes. So therefore, usual time taken by him to reach the office is 60 minutes. Clear? So this is again one more way in which we can again look at it as distance as constant, and then we are moving ahead with the solutions here. Right. Now let's try to understand the same question by using proportionality. If I know that distance is constant, now what is the ratio of their speeds? Let's try to understand. If his usual speed is s, clear, then his new speed is 4/5 of s. Now when I equate this, s gets cancelled. When we cross multiply, this becomes 5:4. Now I need not do this every time. Please understand, 4/5 is the fraction. Right? 4/5 means his new speed is slower than the old speed. So what I do, I put 5 here and 4 here. 5:4 becomes the ratio of their speeds in a very simplified way. Okay. If 5:4 is the ratio of speeds, then we know that the ratio of time taken is inverse when distance is constant. So I can directly think of this as 4:5 is the ratio of time taken. Now, I know that the gap between them is the time by which he is late. So what is the gap between them? That is one part. If one part is equal to 15 minutes, I repeat, if one part is equal to 15 minutes, his usual speed is s1. So the time taken, that is 4 parts, will be 4 into 15, that is 60 minutes. So 60 minutes is the usual time taken by him to reach his office. I repeat, proportionality makes the job pretty easier when you have simplified questions altogether. Clear? Now let's look at one more question here. Let's try to apply proportionality here. Walking at 3/4 of his normal speed, okay. Mahesh takes 2 hours more than the normal time. Let's use proportionality. 3/4, that means his new speed is slower. So I can directly write that S1 is to S2. I give a larger number to his usual speed. His new speed is slower. If S1 is to S2 is 4 is to 3, we can look at T1 is to T2 is inversely proportional. That becomes 3 is to 4. Now the gap between them, obviously in the second case is taking more time. Let's take 3K and 4K. So what is the gap between them? I can say if I'm taking 3K and 4K, so the value of K is equal to 2 hours. 2 hours more than the normal time. If value of K is equal to 2, the usual time, that is 3K. So therefore your answer becomes 3 into 2. That means he is taking 6 hours usually to reach the office. That day he is taking 2 hours more. That means he is taking 8 hours to reach the office. Clear? So proportionality makes the job pretty easy once again. Whenever distance is constant, try to use proportionality. That makes the job pretty easy when we move forward. Okay. Now, let's look at one last question when distance is constant. In the mornings, Ashok goes from his home to his office at a speed of 40 kilometers an hour. This time I'm given the speed. Okay. And he comes back from office to home along the same path at a more relaxed speed of 30 kilometers an hour. Okay. Hence, in the evenings, he takes 6 minutes more than the mornings. Now, there are two ways in which we can look at this, but this question has not asked you the normal time. This question has asked you the distance from his home to office. Now, this is where the game slightly changes. Okay. Now, this can be written in two beautiful ways here. One, you know that distance is constant. We can apply proportionality. Let's do that quickly. Speed, the ratio of speeds. What is the ratio of speeds? I know that one speed is 30, the other speed is 40. That means the ratio of speeds is 3 is to 4. If the ratio of speeds is 3 is to 4, I can say that the ratio of time taken by them is inversely proportional. That is 4 is to 3 is the ratio of time taken by them. Clear? So obviously in the second case, clear? Sorry, I guess I went wrong. Yeah, it's reverse. I'm sorry guys. So in the first case he is going at 40. In the second case is going at 30. So the ratio of speeds is 4 is to 3. Clear? If the ratio of speeds is 4 is to 3, the ratio of time taken becomes 3 is to 4. Right? And obviously in the second case is taking more. So let's take 3K and 4K. So I know that 4K minus 3K is equal to 6 minutes. Okay, which means the value of K is equal to 6. 6 minutes, okay. So if he's traveling at a speed of 40, this guy is taking 3 into 6, that is 18 minutes to cover this distance. And if he's traveling at 30, he is taking 4 into 6, that is 24 minutes to cover this distance. Now the question has not asked you usual time, the question has asked us the distance. So I can do either of the calculations. Either I go with 40 into 18, I repeat, 40 is in the form of kilometers per hour, 18 is minutes. So therefore this divided by 60, 22s, 23s, 3 1s are 3 6s are, which means the distance covered should be 12 kilometers. Clear? So again, units play a very important role when I'm looking at this kind of question altogether. Now, what is the other way of looking at this? Now, the only problem with this is when I use proportionality, remember I am using ratio of speed and ratio of time. That means I will either get speed or I'll get the time. So which means I have to go one extra step to calculate distances further speed into time. Which means one extra calculation is required. Right? Now, can I do this in any other manner where my extra calculation will not be required? Let's see this. Since the question is asking me, the question says the distance is same. One more angle of looking at this question is the time taken by him in the evenings is 6 minutes more. Let me write 6 by 60 more than the time taken by him in the morning. Now what's the time taken? let's say the distance is d kilometers. In the evenings, he's traveling at 30 kilometers an hour speed. Let me bring time taken by morning here. Minus d divided by 40 will be equal to 6 by 60. Now 6 by 60 is nothing but 1 by 10. Let's say this 30 and 40. What is the LCM? 30 and 40, the LCM is 120. So this becomes 4d minus 3d is equal to 1 by 10. 0 and 0 gets cancelled. So in this method, the advantage is we directly get the value of d is equal to 12 kilometers. So we are, by dividing by 60, we are keeping the uniformity same. Distance is in kilometers, speed is in kilometers per hour. So therefore time also has to be in the form of hours, right? So when the question asks you distance and this kind of information is given, we can as well use this approach to directly calculate the distance. So these are certain standardized models which keep coming in the examination. So let's be very clear as to how to use the numbers or the data given to get the desired answer. So it really depends on the way we are looking at the question, and more importantly, as I always say in all my classes, read the question statement before moving ahead with the question, right? So that's it from this session, guys, and in the next session we'll be looking at some other basics. Till then, keep learning. Thank you, guys.